What if the redox reaction takes place in basic solution? Let us try by balancing the oxidation of iodide ion by permanganate ion in basic solution to yield molecular iodine and manganese 4 oxide. So our equation is iodide plus permanganate forming I2 plus MnO2. The first thing that we need to do is to assign oxidation numbers. Let's start with I2 or molecular iodine. According to rule number 1, free or uncombined elements have an oxidation number of 0. So iodine in I2 has an oxidation number of 0. Next, according to rule number 2, the oxidation number of monoatomic ions is equal to its charge. So for iodide ion, iodine has an oxidation number of -1. Let's go to permanganate. So again, by rule number 3, oxygen here has an oxidation number of -2. So what is the oxidation number of manganese? We apply rule number 6. So the sum of all oxidation numbers is -1. The charge of permanganate ion is -1. So we have 1 manganese times its oxidation number plus 4 oxygens times its oxidation number, -2. Solving for x, you will get a value of +7. So the oxidation number of manganese in permanganate is +7. How about manganese 4 oxide? Oxygen here, again, by rule number 3, oxygen here has an oxidation number of -2. And using rule number 6, manganese has an oxidation number of +4. Once you have assigned oxidation numbers, determine which element has an increase in its oxidation number and which element has a decrease in its oxidation number. So we see here iodine from -1 to 0. So this is an increase in oxidation number. So this is our oxidation half reaction. And we see manganese from +7 to +4. There is a reduction in its oxidation number. So this is our reduction half reaction. So we can now write our oxidation half reaction. We have iodide forming molecular iodine. And our reduction half reaction, we have permanganate forming manganese 4 oxide. So after writing our half reactions, we balance the atoms for each half reaction. Let's go to our oxidation half reaction. In the reactant side, we count only 1 iodine, but in the product side, we count 2 iodines. So we place a coefficient 2 on the reactant. Next, we go to the reduction half reaction. Manganese is already balanced, but we have oxygen. We lack two oxygens on the product side. So we have four oxygens on the reactant side, but only two oxygens in the product side. Again, we use water molecules to balance the oxygens. So we place two water in the product side. In doing so, we introduce hydrogen. Now this is in basic solution. But the fastest way to balance this is first to consider that the solution is acidic. So first, we will use hydrogen ions. So we add four hydrogen ions in the reactant side to balance the hydrogens. After balancing the atoms, the next step is to balance the charges on both sides of the two half reactions. Let's go back to our oxidation half reaction. We count a total charge of -2 on the reactant side and a total charge of 0 on the product side. So we place two electrons on the product side to make the total charges on both sides equal. Next, we balance the charges on the reduction half reaction. On the reactant side, we have a total charge of +5, while on the product side, we have a total charge of 0. So all of the molecules in the product side are neutral. So we add 5 electrons. Permanganate has a charge of -1. So the net charge or the total charge on the reactant side is not +5, but +3. So to balance the charges, we add 3 electrons on the reactant side. And these 3 electrons will now cancel out the +3 charge, giving a total charge of 0, which is the same as the total charge of the product side. After balancing the charges, we balance the number of electrons. For the oxidation half reaction, we see 2 electrons, while on the reduction half reaction, we see 3 electrons. So we multiply our oxidation half reaction by 3 and the reduction half reaction by 2. So now we have 6 iodide forming 3 iodine. And for the reduction half reaction, we have 2 permanganate plus 8 hydrogen ions forming 2 manganese 4 oxide and 4 water molecules. So now we add the two half reactions. So we have 6 iodide plus 2 permanganate plus 8 hydrogen ions forming 3 iodine or molecular iodine plus 2 manganese 4 oxide plus 4 water molecules. Now, don't forget, the redox reaction is taking place in basic solution. But we started by using hydrogen ions. So now we will consider that the reaction is taking place in basic solution. So to do this, we need to add the same number of hydroxide ions to the reactant side and to the product side. If a hydrogen ion and a hydroxide ion combines, they form water molecule. So this is now equivalent to 8 water molecules. Now we also have 4 water molecules on the product side. So 4 will be canceled out and 8 here will become 4. So our final balanced redox reaction looks like this. Plus 3 molecular iodine plus 2 manganese 4 oxide plus 8 hydroxide ions. Again, to check, look at the number of atoms if they are balanced. So you have 6 iodines, 2 manganese, we have 12 oxygens, and 8 hydrogens. So the number of atoms are balanced. And check also if the total charge on the reactant side and the total charge on the product side are equal. So the total charge on the reactant side is -6 plus -2 plus 0. So that is -8. And on the product side, we have 0 plus 0 plus -8, which is also -8. So after checking, then we are confident that our balanced equation is correct.